Hello, whoa, out stargazing on another clear, moonless night. Boy, there's so much to see in the sky, and there's so much that's unseen in the sky. Hello, everybody. I'm Stargazer Mark, and welcome to our Stay Star Curious segment of the American Space Museum, where we love taking you up into the space from your own backyard and finding things that you never knew existed in outer space from your own backyard. Today we're going to talk about exoplanets, and here's an artist rendering of some of the planets that have been discovered orbiting some of the nearby stars. And one of them is right in your backyard that I'm going to show you about tonight. It's called the Fish's Mouth. So we're outside in my backyard doing a little stargazing, but I'm going to be talking about the unseen things of our universe, like I said, that you can see from your own backyard. Let me get a sip of my coffee mug here that says caution, may randomly start talking about astronomy. A gift from my co-producer Marty Winkle, who's training a assistant producer. Thank you, Connie McDaniel, for wanting to learn the ropes here and help us. She is one of our awesome volunteers. Connie McDaniel, thank you for all you do here. But let me get that sip. Whoo, boy, that spiked just right to get me through the show today, Marty. Thank you very much. But binoculars are a way to get involved in backyard stargazing, and a red flashlight will not dilate your pupils contract your pupils when they dilate out, and you can read things in the night like a star chart. But sometimes in your backyard, the neighbor's lights are enough to read your star chart by. And only when we're in dark places looking for nebulas and galaxies do you really need to be wary of using red lights and not exposing white light to anybody that might be in your group stargazing. It makes your eyes contract, and dilating your eyes is how to see things in the sky. Well, I was recently asked by a group of people interviewing and doing coverage here at the museum, what, after 60 years of being an amateur astronomer, what awes me? After 60 years of seeing the space age and walking on the moon and all these wonderful discoveries of the Hubble telescope, what does awe me? And I thought about it for a minute, and I said it's an easy answer. Every time I go outside under a starry night and look up at those beautiful stars, I am in awe to the fact that somebody may be looking back. And I'm convinced somebody's looking back from their own planet at our little star in their sky somewhere. I'll never know that for sure because I'll never live long enough. But I am convinced that we are not alone in the universe. And I think after I lay out some of the facts about the planets we've discovered orbiting other stars, you'll agree with me. Well, let's look at what we've got racked up here today. 30 years ago was the first time that we being astronomers, that we discovered planets orbiting another star. And how did they do that? What is an exoplanet? How do we know they exist, and what do they look like? Well, exo is outside of, all right? So this is a planet outside of our solar system. And we have distinctive groups. But behind me is the terrestrial group that looks like the Earth in size, around 10,000 to 5,000 miles in diameter, rocky body. Then we have all these gas giants that are 3 or 4 times the size of our Jupiter or Saturn. Then there's Neptune-like bodies that are around 30, to be the size of Jupiter is 90,000 miles across. So we have discovered gas giants orbiting other stars that are 100 to 200,000 miles across. And I'll tell you how we know this size here in a minute. A lot of Neptune-sized bodies are being discovered that are around the 50,000 mile diameter range. And then again, you've got the terrestrial rocky bodies. Some could possess oceans and atmospheres like Earth. In fact, we're convinced now that some of them do, from the data coming back from the Hubble telescope. And of course, the Webb telescope is going to enhance our knowledge of all this. We have discovered, and that's right behind me here, so I'm teasing you, how many exoplanets have we found? We have found over 5,000 planets circling about 2,000 nearby stars. All right. And they come into, again, they're classified very easy categories that we find these in. They're classified as gas giants, about 30% of them. About another third of them are super Earths, meaning they're rocky bodies, but they're as big as Neptune. And then you've got another third of them are Neptune size, the 50,000, 30 to 50,000 mile range. And only 4% of them that we've discovered so far are what we call terrestrial, like the Earth. And that makes sense because they're smaller. It's harder to find the small things in space. It's easier to find the big things in space. And exactly how they're populated in the around our nearest space area here is we've got a lot of them. There are some lava worlds we think there in the green and lower left are actual planets that have flowing lava on them. Ocean and ice giants make up a great portion of them. They're what they call hot Jupiters that are exoplanets the size of Jupiters that are extremely hot, and we don't understand how they can keep their atmosphere being so hot. And then cold gas giants are part of the layout of our planets there. Well, here's how we know that other planets are orbiting other stars. The first way we detect is that the planet moves in front of the star, and we are exactly in the line of sight where that planet dims the brightness of the star. And this was the first way that we discovered planets. And they think actually 1917 astronomers may have saw the first exoplanet and thought it was another star orbiting a planet. But the first ones actually confirmed were in 1992, 30 years ago. And by the technique also of where a planet can tug a star back and forth, all right, and we actually see the movement of this star against the background of the sky. And spectral movement, you see up there, you got spectrum at the top, and the spectral radiation movement can be detected as the spectrum changes. We don't see the star move in front of it, but it changes the light properties of the star, and we know that something is involved in it there. So it is very technical, and we have not seen any of these exoplanets, 5,000 of them, until last month when the Webb telescope photographed the actual surface or atmosphere of an exoplanet. And I'll show you a couple of those pictures here in a minute. Potentially habitable exoplanets. There's a lot of them. They've got a lot of weird names. Kepler is a spacecraft that we orbited to find exoplanets, a NASA telescope that we put up there specifically to detect around the nearest stars whether planets were transiting in front of the star or could be detected by the pull of the gravity and or the spectral analysis of the star. So there you got 2, 4, 6, 1, 2, 3, 4. You got over 30 planets orbiting other stars that we think could harbor life. Why do we think that? Because the analysis of the spectrum of these planets reveals water vapor. And we know that where there's water, there is life. There could be other forms of life based on silicon or instead of carbon, but we're looking at life as we understand it. Now, what is the habitable zone that we talk about of planets? The habitable zone in Kepler, again, these are some of the prime candidates where we could find water vapor and eventually life on these planets. And these are some of the planets that I say I'm in awe of is somebody looking back at us every night as we look out from our third rock from the sun. Well, to be habitable, the temperature has to be just right, like on Earth. Mercury and Venus are too close to the sun. They're too hot. And Mars and Jupiter and Saturn are too far away from the sun. They're too cold to have liquid water on the surface, like on Earth. So it's just like Goldilocks and the Three Bears and the porridge. Some of the porridge was too hot, some was too cold, and then one of it was just right for Goldilocks. And astronomers do call this the Goldilocks zone, is where we're looking for the sweet spot where water vapor exists on the surface of a planet. It's got to have life because the Earth does. And there's one Kepler 452b about the size of Earth orbiting another star that could possibly have water vapor on it. This is again some of the planets in relation to the Earth. Most of the planets we've discovered are a lot larger than the Earth, over 5,000 of them. The closest star system and closest planetary system to our solar system, Alpha Centauri, is 4.3 light years away, over 4 light years away. That's traveling at 6 trillion miles a year, or which is 6 trillion miles an hour. Is where you're going. 6 trillion miles an hour in 1 year. You wouldn't even be a fourth of the way to the closest star, Alpha Centauri. And we know that star has a couple planets going around it. So everywhere we look, we think we're going to be seeing planets. About 1,000 of these systems have more than one planet. Not all of these planets are round. In fact, this is an artist's conception of a rugby-shaped planet named WASP 103b. The European Space Agency's Cheops Space Telescope found this planet twice the size of Jupiter, zooming around its star in just one day. And the tidal forces have tugged this into a rugby-shaped ball, like a football. With rounded points. So ultimately, it was probably spherical and deformed in this by the planet. Well, we're going to look up into the night sky right now and take a look at, let's see, the night sky there is, this is from Stellarium, a planetary program for your computer or your smartphone. Think aquarium and stellar aquarium, stellarium. And as you look out tonight, there's no moon in the sky. You're going to look directly to the south, all right, which here in Titusville, that's looking towards Miami. All right, all of our friends in Michigan, just look away from where it's the coldest. Look to the south, okay? And you're going to see bright Jupiter up above. And then there's going to be Saturn to the right of it. And there's going to be a star, pretty bright star, right in below Jupiter and Saturn. And that star is called Fomalhaut. It is in a constellation called the Southern Fishes. And there I've outlined the constellation borders that we're looking at the sky. See Jupiter in the upper left, Saturn in the lower right, and Fomalhaut's in the middle in what they call Piscis Australis, the southern fish. Jupiter is in Capricorn. Aquarius is the faint stars in between all of this area there. And Saturn is actually in Capricorn. Sorry about that. Saturn's in Capricorn. And so Fomalhaut is very easy to see because it's really the only star, bright star in this area. And you remove Saturn and Jupiter, which Saturn will be in that area for another 5 or 6 years, but Jupiter, as I'm going to show you in another slide here, moves about your fist held out at arm's length to the left every year. Over 12 degrees does it move every year, so it goes around the zodiac once in 12 years. So Fomalhaut is also called in Arabic, an Arabic name, the Lonely One, and because it looks so bright and it looks so lonely in the sky. But if we could look at it differently, and there's Jupiter. Last year, it was right there, closer to Saturn, and look at how far that it has moved in 1 year away from Saturn there at the bottom right, where it was real close to it. Celestial motion in action there. But if we could put on some X-ray goggles and magnify it, when you look at Fomalhaut there, an area twice the size of the full moon. If we could cover Fomalhaut with the full moon, which is a half a degree, and add one other full moon size to it for 1 degree of the sky, you would see this incredible sight of a ring going around this star called Fomalhaut. And that is the orange star in the middle. This is a Hubble telescope photograph of this. The Webb telescope will be looking at it soon. And in a very detailed look here, you are looking at the location of Fomalhaut. And with some special technology, we actually see a dust ring around this that would be twice the size of the moon. It would stick out if you could see it incredibly. You need your thumb arm's length to cover it up, which is pretty big in the sky. And they have even found, as you see there, Fomalhaut B planet, where it has moved and right off my shoulder from 2004 to 2006. So incredibly, a star that you can see tonight, right below Jupiter and Saturn, easy to see, Fomalhaut has planets orbiting around it. And we don't know how many yet, but this is an infant solar system because it's got so much dust in it and scattered around in there. And again, astronomers really don't understand exactly what's going on except within the confines of the laws of physics that we understand. But what we're witnessing now with the Webb telescope will reveal a whole new side of astrophysics that will produce great things in the future, I'm sure, of our understanding of what's going on in our universe. This is an image, again, that the Hubble telescope took of another star system. You've got the location of the star and the location of right over here, that where that arrow is, location of HR 4796b. That is a planet that is orbiting this debris ring of this star. And this whole area is incredibly huge. This is 150 billion miles across, all right, 150 billion miles. Pluto's about 4 billion miles away. And the two spacecraft that have left the solar system, the Voyager 1 and 2, they're about 12 to 15 billion miles away from the sun. So this is an incredibly huge slice of space, and yet we see what could be the Oort cloud of an extra solar system out there. The Oort cloud is the reservoir of comets that we think is 30 to 100 billion miles away from our Earth. So who knows, but we're going to be seeing some amazing photography like this from the Webb telescope. Are you kidding me? You are looking at the first released images of a planet. That is the disk of the planet that you see along the bottom. That is the star that this planet is orbiting. And you see the little, in the center is the planet, and on the outside of it is some sort of atmospheric phenomenon from when this planet was born, maybe very recently. This is what we're going to understand is the evolution of planets. One thing weird about all these planets that we see, and there's our 3 planets in the sky. We'll talk about those in just a second. What is weird about all these extraterrestrial planets that we see out there is the big planets are close to the star. We thought that the terrestrial planet, the rocky planets, would be close to a star because the star's energy would blow off the outer layers of atmosphere. So that makes sense that Mercury doesn't have an atmosphere, just 80 million miles from the Earth. Venus has got a dense atmosphere that was created by a runaway greenhouse effect in some manner. And then the Earth is a rocky body, but the rocky bodies of our solar system are the first planets, all right? Mercury, Venus, Earth, and Mars. And then the gas planets that have a rocky or icy interior are out at the end of our solar system. We're on these exoplanets. It seems to be just the opposite, where the big planets and gaseous planets are close to the sun, in fact, orbiting the sun in phenomenally fast speeds, like taking just days to orbit the sun, their sun. So these are the things that we need to learn about. Of what awes me is that exoplanets are now real. And so you roll the numbers, okay? If there's so many of these planets, 5,000 of them, around the closest 700 or so stars near our own solar system, 700 stars is nothing when you consider a galaxy is full of 100 billion stars. So for the number of stars out there, there's more planets. So if we have 100 billion stars in the Milky Way galaxy, astronomers are theorizing we could have up to 1 trillion or more trillion planets orbiting these 100 billion stars. And come on, folks. I've always thought it's the height of arrogance of human beings to think that we're the only living creatures in God's creation of this wonderful universe. A higher power, a God, an entity, whatever you want to think about, as something that is the creator of this solar system. But I'm going to tell you what is the creator of our universe in general are the laws of physics. And I always revel in the fact that the atoms of this piece of paper, all right, that are this, they undergo the same physics principles that stars orbiting galaxies do, or planets orbiting stars do. The laws of physics don't change throughout our universe, and it took great minds like Einstein and Hubble and the early astronomers like Kepler and Copernicus, and of course the great Isaac Newton, in stages to figure out what our universe is exactly like. And now we're thinking of alternative universes. We're thinking of instead of 3 dimensions, 4 dimensions, and it's just mind-boggling to think about our world, the Earth, a tiny, not even 8,000 miles across, 70% of us covered in oceans, a beautiful purple, bluish marble in space. Anybody would be attracted to our planet in our solar system. They would say, that is where life is. Look at that water. Look at that atmosphere. That's the first planet of this solar system we need to go to. And who knows, maybe that's what's going on. But it is very interesting to think about. We are not alone. Well, we're not alone in the night sky, as we've got 3 planets up there to beautifully occupy us. As I'm going to take you star curious on this Stay Curious, looking at the planets that are in our sky right now. Get out there and look at Saturn, because it sets around 10 o'clock at night now, but it's getting dark, of course, around 5:30 or 6. We astronomers like that, okay? I'm also a golfer, so the golfer in me doesn't like that, because I'm yawning and thinking about going to bed at 8 o'clock, and I've teed off at that time in the summertime and got 9 holes in. So it is a strange time, but again, this is celestial mechanics when you're witnessing this change in our seasons, and this is all caused by the Earth's being tilted at our axis. So if we were straight up and down, every day would have the same amount of daylight and darkness depending on where you were on the latitude of the Earth. So because it tilts, we go from, a little under 10 hours of daylight in the wintertime to the summertime almost having something like 18 hours in there. So the planets to look at in the sky, and we're going to talk about them more on our Stay Star Curious programs, of course, are Saturn, Jupiter, and Mars. This is showing them in about their relative size ratio, how you see them in a telescope. This is a pretty decent view of what you'd see in a telescope as far as detail on the planets. We're looking at the surface of Jupiter and Saturn, not the surface. We're looking at the cloud tops of these, and of course the rings of Saturn. With Mars, only the moon and Mars can we see the surface of through a telescope in your backyard. And the surface markings on Mars kind of relate to darker areas and they're lowlands, and some of them are highlands, but they're basically higher areas that are not mountainous. There's no real mountains on Mars. There's higher areas among the plains, and the red areas are the desert plains that have microscopic dust being blown around, finer than talcum powder. And last opposition of Mars, when it came close to Mars, we had a global dust storm that hid the surface of Mars. And space farers haven't thought about that. This is a regular occurrence. About every 10 or 12 years, Mars experiences a global dust storm where we cannot see the surface, and that certainly would wreak havoc on any habitats on the surface of Mars. They'd have to be ready for it, and you would not be able to use your solar panel energy because the sun's light would be obscured that much. So just something you don't think about. But look at those dark mottling, dark areas on Mars there. We're going to look at a couple other pictures of it close up. But in a backyard telescope, and I encourage you over this holiday weekend with your friends and families, look up the nearest astronomy club, because certainly they'll be having some stargazing going on for the public to show you the 3 planets that are up right now. This is what Jupiter would look like in pretty much in any kind of low power telescope. You're going to see the surface. Jupiter is squished. Do you notice that the equatorial area is bulging out? So it's actually about 88,000 miles at the equator, but only about 85,000 miles from the poles of Jupiter. And those stars that we see, those aren't stars, those are the moons of Jupiter that Galileo discovered in 1609, just over 400 years ago. Have we known that Jupiter has moons going around it? These, of course, moons are pretty big. One of them is larger than the planet Mercury, over 2,000 miles across. 2 of them are about the size of our moon. So, and they're active worlds of their own, just like looking at exoplanets. This is like looking at worlds of their own. We don't know if there's life on Europa, which is one of the moon size of our own Earth's moon. It has oceans beneath the ice on this structure. And of course, we have analyzed as close as we can with spacecraft these 4 moons and Jupiter. In fact, the spacecraft Juno is orbiting Jupiter right now, going out way past these moons, about 2 million miles, and then dive bombing in about 6,000 miles above Jupiter's surface. This is how tiny Saturn can look in a backyard telescope if I brought it to your house. But still, you're going to say, wow, I see the rings. Yes, they're there. But this is a good way to emphasize that it's a pretty tiny object in most backyard telescopes. Some of my astronomy friends that can have the better, more expensive scopes that are bigger and do photography can show you better images like I'm going to show you here. And there's Mars. Typical image, the way you're going to see Mars in a backyard telescope. Yes, that's the hint of the polar cap at the top, and those dark markings are real. And because Mars rotates every 24.5 hours, just slightly longer than Earth's rotation, you can watch these features over a couple hours of viewing move across the surface of Mars. So I'll go out and look at it and say when it starts to get dark real good and it's high up about 8 o'clock, and note where the markings are, make a sketch, and then go back out at 10 o'clock and the markings have moved and new markings have revealed themselves. This is the fun part of being an amateur astronomer and being very active looking at things from your own backyard. Here's a good photograph by one of my astronomy friends showing the red spot, the famous storm on Mars. It's like a cyclone that we're seeing the top of it. Why is it red? We don't know for sure. There are some inorganic materials. There's some interaction with sunlight and the hydrogen and ammonia that comprise these belts. When you're looking at Jupiter, the bright areas are higher up, and the dark bands we're looking at the top there's actually looking deeper into the clouds. And why they stay like a trench, so to speak, is a puzzle still to planetary scientists. There you see at the top a black shadow of one of the moons being cast in the upper right up there. That moon is casting a shadow from the sun onto the cloud tops of Jupiter, and you can see those in a backyard telescope, and they're very fun to watch, as well as that moon on the left side of Jupiter might be going behind Jupiter and being occulted by it. And also moons will pass in front of Jupiter and we call that in transit. And within hours at the telescope, you can watch this celestial mechanics happening. And then the glorious Saturn from your backyard. My gosh, that does say astronomy. And, you know, when I was asked about things that make me in awe of looking up at the sky, well, besides thinking about, is anybody looking back? I can never ever tire of looking at the rings of Saturn. I don't know how many hundreds of thousands of times I am sure I've literally looked through a telescope at Saturn. I frankly hope it's the last thing I can look at in my dying days is Saturn through a telescope, because it looks so unreal and so majestic. And in the bigger telescopes that astronomer amateurs have in clubs, you can see an image like this. It's just breathtaking. We know now by the NASA Cassini spacecraft a lot about these rings. As you see, they have different densities. The outer ring isn't as bright as the inner ring, and then there's a very inner ring that looks darker. Yes, the rings, and then the rings are split by a distinct division. Well, Giovanni Cassini, an Italian astronomer, old Gio was the first one to see this distinct division in the rings of Jupiter, and it's called the Cassini division. And what has happened is Jupiter has 60 some moons, and about 15 of them are inside. There's about 10 moons that are less than 10 miles in diameter that are inside these rings, clearing out other Cassini divisions. This was a big object that cleared out some of the debris there. Well, what debris am I talking about? Well, the debris on the outer ring there is darker material, more like rocky asteroids from maybe the size of a house to down the size of a good sized boulder, lightly frosted maybe. The ones in the bright ring are ice bodies or other smaller bodies that are coated more with ice, all right? Yes, H2O water ice is what these are coated with. And it's just so gorgeous. I encourage you, when you're bored over Christmas holidays, go to Cassini, NASA Cassini, look up these fabulous images. And it is so incredible what you're going to see there. You're going to see what they call the shepherd moons moving across there. And just like a wave, there's a wake of debris being following this moon as it moves around Saturn's rings. But one unreal fact that I want to emphasize to you all is these rings of Saturn are about 200,000 miles from tip to tip, all right? That is the distance from Earth to the moon. 240,000 miles is the average distance of the Earth to the moon, so fudging a little bit. But think about basically that the rings from the left side to the right side is like going from Earth to the moon. Well, how thick are these rings? How many miles thick do you think these are? No, not miles thick. These rings at no point are more than 1/4 of a mile thick. That is less than 1,500 feet. All right, folks, that is a ratio of a sheet of paper that you all know, an 8.5 by 11 sheet of paper. If the rings are from the tip of the sheet of paper, they are the thickness of this sheet of paper. All right, that is the ratio of 200,000 miles to 1/4 mile is this sheet of paper. All right, stretched out 20 miles. That's what I forgot to say. Imagine a sheet of paper 20 miles wide and the thickness of this 8.5. That is incredibly thin. And yes, as I'm flopping this sheet of paper around in front of my face, that is how these rings act. They are held in place by these moons. Isn't that amazing? So go look up these Cassini images. One other question. How long have these rings been there? Nobody knows. There's no time clock out there in our solar system for when things were. We can kind of figure things out geologically on the moon, and we know can bring back rocks like we did that we can analyze it. We know moon rocks are around 4 billion years old, just like Earth is over 4.5 billion years old. But we don't know how old these rings are. Are they 100,000 years? Heck, they could be 10,000 years old. They could be 100,000 years old. All right, because mankind has literally seen these for the first time in about the 1620s. Galileo couldn't detect them in his little 8-power telescope. He saw that Saturn had what he thought was like ears on the side of it. It had protuberances on it. Those were the rings that he was looking at that he couldn't resolve with his very cheap telescope, that yet powerful. These binoculars are a lot more powerful than what Galileo had. But we don't know if these have been around 1,000,000 years, 10 million years, 10,000 years. We really don't. So that asks the question, did Earth ever have a ring around it? Or Mars? Or Venus? Or Jupiter? Are rings around objects in the solar system a common thing? Well, you know what? Yes, we know it's a common thing because Jupiter has a ring going around that you can't see from Earth. It's more like a ropey hula hoop, if you remember those little hula hoops that we used to play with as kids and hula hoop them around our waist. Well, Jupiter's got a couple rings like that going around it. Uranus has some rings going around it that seem to be broken up. They're not complete rings, they're segments of rings. Is this a moon that came too close to the gravity Roche limit, they call it, around a planet where the gravity will pull things apart? Could be that this is how rings were formed, most logically, and maybe we're seeing the rings of Uranus being created before our eyes because they're surely about 8 or 10 ringlets. And then Neptune has a series of ropey rings going around it. So 4 out of the 8 planets, excuse me, 9, because I still say Pluto's a planet, 4 out of our planets have rings going around them. So we know it's a common thing, and that poses the question when you're talking about exoplanets, what exoplanet are we going to find the first ring around? I guarantee it, and it's going to be a ring around the rosy for those astrophysicists and astronomers out there to find that first ring system around an exoplanet. Well, I hope that you've enjoyed looking at planets in our solar system as well as over 5,000 planets. Everywhere we look is a planet going around a star in our backyard. And there's some rocky ones, there's some that have active oceans and ice on them. We're going to learn so much more about this by the Webb telescope, that exoplanets are going to fill the sky. Like I said, if there's 100 billion stars in our Milky Way galaxy, and most of those stars have 1 or 2 planets around them, my gosh, there are dozens, 10 times more planets in the sky than there are stars. Think about that, and think about how we could possibly be alone in the universe. I just don't see it, and that's what awes me about being an amateur astronomer, is the fact that we have learned so much in my lifetime, and you wish that you could live to be 200 years old instead of your late 80s, which is a life expectancy now, so that you could see these amazing discoveries that we're on the cusp of, with some of the greatest scientific tools man's ever made, the Webb telescope and the Hubble telescope. And having both of those work together at the same time is going to yield some groundbreaking science that we're going to keep you on top of here on Stay Curious. So I hope you've enjoyed this, and until the next time that we bridge this space between us, I'm Stargazer MarQ saying, come to our museum, look up, be in awe, and I'll see you again to bridge the space between us.